Rhythms. Now, one of the reasons why we do inverses is because of logarithms, and the logarithm is kind of an interesting creature. It is the only function that we know of is defined in terms of another function. He exists to serve a purpose, and he exists to be the undo button of the exponential function. So that says log base b of x is equivalent to b to the y equals x. Now, what do you notice about this strange thing, which my finger is, you can't see anything, but it's on your paper. This thing guy right here, what is different about him? B to the y equals x. Is that a fly? They've risen from the dead. They followed me here. B to the y equals x. What's strange about that? That doesn't look normal. It's the power of y instead of the power of x. And you notice x and y have been what? Switched. What switches x's and y? The inverse function. So what you have here is the logarithm is by definition the inverse of the exponential. Now, when we look at x squared and square root of x, we didn't define x squared and square root of x in terms of each other. They just were. In this particular instance, logarithm, it says logarithm is being defined to be the inverse of the exponential because you're flipping x's and y's. Now, when we look at how we write this thing, it says log base b. So if I were to look at log is on the baseline, and then you have an x, and it would be like log base b. That's a little subscript. So it's down, like we have essentially exponents are up. This guy is down. That tells me what base we're dealing with. Now, our calculators have two bases. It has base 10 and it has base e. So you can have logarithms to any base as long as b is positive and b isn't equal to 1. Because that's the base of the exponential. The base of the exponential has to be positive, and it can't be equal to 1. So how does this thing fit together? Well, this is how this guy's going to work. My college algebra is every time I draw two circles, they start groaning. It's like, oh, not again. But yeah. This is the domain. And this is the range. And what we know is this, that b to the x power picks up x values, takes it to y values. So that's essentially what we know. What we've just done is we have now defined a function, and it is a function, and we call it log base b, that's going to pick up y values and take it back to x values. So log base b of x is, by definition, the inverse of b to the x. And you're going to say, well, how do I know it's the inverse? This is log base b, and the exponential is base b. So we have log base b, and the exponential is base b. They're inverses of each other. So that says that b to the x takes x to y, and log base b takes y back to x. So that completes that circle. And it is by definition. Now, here is something else that's kind of interesting, and we'll come back to this again. But we know that the domain of the exponential function is all real numbers because there's no denominator and no radical. So the domain is all real numbers. And then we know what the exponential looks like. The exponential looks like this guy right here. So the exponential's range is from 0 to infinity. So that means in this box is 0 to infinity, which is going to set us up for a specific domain. Logarithms only has in his world 0 to infinity. So the logarithm is going to have a domain issue. It's the last thing we're going to add to domains. Remember all these problems that you've got now at the beginning of all of the worksheets? Domain, 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 domain. We're going to add one more thing. And it'll be the last thing ever. Even in college algebra, that's the only thing. We only have 3 things that we need to watch out for domain. But that's kind of how they fit together. Now, if I take a look at my calculator, and where the logarithm is on my calculator, there's log, and if you look above it, you see 10 to the x, and that says log is base 10. So that's the base of that logarithm. It's called a common log. And ln is actually called natural log, and we're going to work with him. And in fact, that's the logarithm you work with most of the time. And you notice above natural log is our old furry friend e. That says the natural log is base e. Above the keys of the functions, remember, are the inverses. Above x squared is square root. So we talked about the trigonometric functions, and above the trigonometric functions are their inverses. So when you look at log and natural log above and x squared above that key, because those are functions, above those keys are their inverses. Are their inverses.